I personally would like to see a simulated potato field with the fidelity of the Unreal simulated city they used in the newer Matrix movie. That'd be pretty cool. I would just go hang out there. Welcome everyone to OpenCV Weekly Webinar, episode 59, if you can believe that. I am your co-host with the co-most, Phil Nelson, sitting in the big chair. Well, it's the same chair. Dr. Satya Malik is on assignment. Joining me in his stead is Anna Petrovicheva. Said her name wrong again. She psyched me out. Anna, please introduce yourself. Say hi.
Hi everybody, hi Phil. This was actually super close. My surname is definitely hard to pronounce, so yeah. So I'm with OpenCV for 12 years now, doing computer vision of different flavors. And yeah, acting as a CTO of OpenCV.ai.
Awesome. Thank you, Anna. And our guest this week is Michal of Team Potato Lovers. Go ahead and introduce yourself, Michal.
Hello, I'm Michał. I'm from Poland. Nice to be here today.
Thank you. So if this is the first time joining the webinar for any of you in the audience, or if you just need a reminder, there are a few things we do every single week here on OpenCV Weekly Webinar. One of those is we take Q&A from you in the audience. Please use the Zoom Q&A button at the bottom of the window there to ask your question at any time during the show. If you're not in Zoom, you can get there by going to opencv.live. We also give a trivia giveaway to one lucky winner of a question that I will make up based on the slides. Stay tuned for that later in the show. They will win $200 of Microsoft Azure credits from our sponsors at Microsoft Azure. Thanks to them and Intel for sponsoring this episode of the show. Michal, it's your show. I'm going to go ahead and share the screen so you can get started with your presentation.
Okay, great. So during the presentation, I'm going to show how we used AI and machine learning for precision pest control. We're gonna go through the bid process, and I'm gonna show our story of the competition. So we called our team Potato Lovers. So the team consists of two members. The first member is Marta. Marta is an accountant. She has no IT background, but she was involved in the project. She had many tasks. There were many tasks she could do as a non-developer. And I'm the second member of the team. My name is Michał Rzepka. I'm embedded software developer with a networking background. I work for a small company in Poland, and I'm prototyping devices.
So one of the things we love about doing these competitions is that we get to be a lot of people's first AI project, and it's awesome that we got to do that for Marta here.
Yeah.
So tell us a little bit about the Colorado potato beetle.
Yeah, so the Colorado potato beetle is a small bug which eats potato leaves. As you can see on the photo, they destroy growth by eating the leaves, and they look like on the picture. So they have yellow and black stripes on the shells, and they potentially could destroy potatoes because they just eating them. And we can move forward. So we can fight against Colorado potato beetles in many ways. One of the way is to gather them by hands, but that's really tedious work. And my grandparents were doing that like that way. So they were gathering by hands. And another way to, sorry, could you go back? Mm-hmm. Another way to fight against Colorado potato beetles is to spray them with pesticides. But as we all know, awareness of chemicals in food is increasing, and people try to avoid that because it's unhealthy. So our idea is to do something with the problem with Colorado potato beetles.
One question: how many of these beetles would you find on like an acre of land
maybe
during the big season?
Maybe we should talk about meters. So
Yeah,
I think that
sorry.
you could find
a square kilometer. No, like what about like 100 meters? Tell me how many would be in
I
100
think
meters.
in 1 square meter you could find 100.
Okay, so we're talking thousands in
Yeah,
a larger. Yeah, wow.
even millions on a huge.
And how large are they in terms of just
They are
adults?
around 1 centimeter.
Yeah. So like I mean that's not a small bug. Like that's something you can identify.
Yeah, exactly.
Cool.
It
All right.
seems, Phil, you have never collected potatoes, did you?
No. No, they don't. They didn't grow them in the Nelson family. We'll have to ask Joseph Nelson about that. I think they only do corn.
Because I did, and this is the reason why I super love the project. Because you can believe it's a super tedious work to find these like nesty beetles and kind of put them somewhere away from your precious potato leaves.
Exactly.
I
Really
do
hard
recall
work.
having to a few times some potato plants or some tomato plants got infested with hornworms, and those things were difficult because those are like yay long, and they'll try to fight you. Luckily they're slow and very dumb. Go ahead.
Okay, so our idea was to create a vehicle which moves along potato rows and detects these bugs. So what we wanted to do was to put the camera, the OD light camera, on the top of the vehicle to allow us to detect these bugs. And then with the information about the location of these bugs, we could spray them point-wise. So that would reduce amount of use pesticides a lot of. So we just want to reduce amount of chemicals used to protect potato fields. So that's our idea.
So another question: What was this an idea you had before the competition, or was it something that you came up with based on the prerequisites of the contest?
I had thoughts about this idea before, but I had no motivation. The competition give me a motivation to do something with that.
See, if Satya was here, he'd be so happy to hear that. I'll have to remind him. No, it is true though. Like I think having goals imposed sometimes gives us extra motivation to do them. The constraints actually make it more likely we will succeed because there's a goal, versus just a nebulous idea that you might like to do. Having a concrete time frame that you have to do it in sometimes is the forcing function that makes it possible, really. So that's cool. It's good to hear that OpenCV Spatial AI contest sponsored by Intel and Microsoft Azure was able to do that for you.
Great. So as for the vehicle, we choose to use a Lego Mindstorm set, which provides us a way to build 5 different robots. And in the box there are like hundreds of pieces, few motors, Lego hub, it's like a microprocessor, and microcontroller, and Lego provides great support with many instructions. So we just were following step-by-step instructions to build our robot.
Yeah, and people watching the webinar will likely recognize this Lego set from some of the other contests we've done, even this most recent one. But this is also the basis for Charlie, the grand prize winner of OpenCV AI Competition 2021.
Yeah, the set gives a lot of opportunities to build many robots.
For example.
For example, so we choose MVP robot. That's the one of the 5 possibilities, and so it provides a robotic arm, but it's kind of crane. So we needed it to be able to aim onto these bugs, as well as. Could you go back?
Yeah.
As well as Lego Hub, which allow us to communicate with Raspberry Pi or any other computer through the serial communication or Bluetooth. Okay, we can move forward.
Cool.
Yeah, so that was the phase of assembling this robot.
It's a
Probably
lot
the
of
most,
pieces.
yeah, exactly. Probably
So
the,
tell
the
me,
most, yeah.
sure. So tell me, how does it feel? Does it feel like you were kind of, does it put you back into kind of childhood years when you were so excited to, play with things?
Yeah, exactly,
Because it has
exactly.
this vibe, right?
Yeah, exactly. That was the most joyful part of the project, and we were waiting for that part. And
About how
yeah,
long did it take to assemble just the Lego kit?
it took like few evenings.
Makes
Few
sense.
evenings.
Cool.
So as you can see, there are many motors, the Lego hub, and many parts. So we had possibility to modify the robot because there were many parts which left after building the base robot. So we could modify to adjust the robot to our requirements. And of course, there was also the instruction to follow step by step and build the robot. Yeah.
All right.
Okay, so
I recognize that guy. That's what I'm using for a webcam right now, in fact.
cool. So we've got the Oak Delight camera for the project. And first thing we did was to try as many examples and demos as possible. They were very helpful for us because they show many aspects which camera allow us to do. Well, actually, the camera, the demo shows possibilities of the camera. And so we tried many examples to be aware of what we can do with this camera. And of course, we also read the documentation. And surprisingly, the camera is very small. We've been expecting something much bigger, and the camera is really small. And it's really powerful, which we're gonna see in the next slides.
Yeah.
So the next step was to introduce ourselves into machine learning. As I said, we were not experienced with machine learning. I did some small projects, some small student project long ago, so we can consider us as unexperienced. So, as I said, first thing we had to try many demos, examples, read documentation, and we started to preparing our data set. So we gathered many hundreds of images of these bugs, these Colorado potato beetles, and we started labeling these images. So it took us also a lot of time, and we used for that reason, for that purpose, the label image. That's a Python program, very useful and easy to use.
Yeah, I've used that one before myself. How did you capture these training images?
We because that no, it's off season because there are no potato plants now, so we had to improvise, and we created artificial bugs. We printed photos and cut out of the photos these bugs and give them a shape of the bug and made up photos, and also we used images from the internet.
Makes sense.
So we used YOLO v5 model also in the project.
Any
That's
particular reason for choosing that version of YOLO
not
or
really.
YOLO?
Not really, because as I said, we were not experienced, so just we like the examples with YOLO v5 model, and we decided to use.
Yeah, and it's very fast, especially on Oak Delight. Yeah.
Okay, so the learning. Okay. The learning process with Jupyter Notebook. So to learn our network, we used a Jupyter Notebook example from Luxonis repository. It was very useful. The one notebook provides us the whole process of training our custom network, from the choosing the data set to actually generating ready to use blob file. So these examples from Luxonis repository were very useful and also user friendly. So we had some experience with Jupyter notebooks, but the notebook from the Luxonis was really easy to read and to get knowledge about what we are doing, actually.
Yeah, the documentation for OAK-D and the whole OAK series with Depth AI is just super easy to get started with. I agree. It helped me out a lot too.
That's the best point to start doing something with OD. Okay, so during the training process, we reused Microsoft Azure because we had no access to a powerful computer around us. So thanks to the sponsors, we had possibility to use Microsoft Azure servers. So we picked a Ubuntu image and we just launched the Jupyter notebook mentioned in the previous slide on that server. We connected with that notebook through SSH tunnel, and we were just working like on the local machine. The huge advantage is that the most of required tools were already installed on the image, so that made it easy.
Yeah, and what kind of how long? What was the speed like here? I know all the contest participants got access to Microsoft Azure with the super fast Intel hardware. How did it work for you in terms of the workflow? Like when you needed to say change something, how fast was it?
So to train our network, we needed a few hours, like 8, maybe 10. So that was a complete process.
Right on. And yeah, and if you didn't have access to this, it probably would have been like a week,
Yeah,
right?
exactly. So the next part of the project was to create a spray gun to actually be able to spray the pointwise these bugs. So we've created the whole system. We based on low voltage water pump, and we've created an electronic circuit for power supplying that water pump. This circuit was controlled by Raspberry Pi. We've used E2C interface. And as you can see, the pipe from the water pump just go along the whole vehicle and end at the top of the robotic arm.
This is my personal favorite part. I'm a huge fan of anytime we combine electronics and water.
Yeah, we both like risk. Okay, so there you can see the top of the gun. Actually, it's made of the end of the perfume.
I was gonna say, is that from a spray bottle for this? I love it.
Yeah, exactly. And as you can see, the range of the gun was like 10 centimeter, and actually it was pointwise, so it matched our requirements. Yeah, that's simple, but it works.
Yeah, sometimes the dumb solutions are the best ones.
That one. Okay, here we can see a video of when we were testing our spray gun. I'm gonna launch the test script from laptop and test the spray gun.
I was hoping that you would accidentally have it. I mean, the classic thing to do would be it doesn't work, and then you point it at your face, and then it squirts you in the face.
Not this time.
Maybe next time.
So yeah, so that's the spray gun.
Very cool.
It was a simple system with some small water pump.
Mm-hmm.
Okay, so vehicle is assembled, so it's time for coding. And as you can see on that picture, there's a whole system. So on the rear of the vehicle, we can see the jar with the water pump filled with water. On the top of the robot, there is a OD light camera, which is connected in the middle with Raspberry Pi. And below the Raspberry Pi, there is a power bank. And below the power bank, there is a LEGO hub. And there is the gun at the end of the robotic arm. We can hear you.
It's a very imposing figure. If I were a Colorado Beetle, I would be terrified of this thing.
That's why we called it Colorado Beetle Buster.
All right.
Okay, so next step was to connect OD light camera with Raspberry Pi. So the camera provided us object detection and deep image, and the Raspberry Pi receives this information from the camera and process this information to control the whole vehicle. So once again, Luxoni's examples were very useful because we based on these examples to get knowledge how to deal with these images with pipelines and generally with the deep AI framework. So we had a problem with power supplying, and we had to create a USB-Y cable because we had an inefficient power source for supply the camera. But so we separated the data lines and the supply lines, and we created a USB-Y cable.
Yeah, we heard a similar thing from Team Midwest Defenders, that they had to do a little bit of DIY with regards to the power supply.
Yeah, exactly.
This is pretty interesting. Did you have to make this one, or was it a part that you were able to acquire?
I made it by myself.
I like it. Again, I love it whenever there's water and exposed electronics. It's my favorite. It's my favorite thing.
You can see my work in the picture. There is a USB-C connector.
Sounds like black magic to me here.
Okay, so the next step was to connect LEGO Hub and Raspberry Pi. So we connected these two microcontrollers over the serial port, and the LEGO Hub is running MicroPython and executes our scripts, and the Raspberry Pi sends commands to the LEGO Hub, like run the vehicle, stop the vehicle, or rotate the arm to a specific position. So we created an interface to manage the LEGO Hub.
It's cool. The commands there remind me a lot. I don't know if you're probably not old enough, but have you ever used the logo programming language? There's this little turtle, you draw stuff on the screen, you can say go forward, turn left, that sort of thing. It's from 1 million years ago. We talked about it on the webinar episode with Kat Scott from Ross not long ago.
So another challenge was to actually translate detected object coordinates to robotic arm movements. So the first task was to convert coordinates of detected bug from the camera point of view, camera perspective, to the point of view of robotic arm. And the second task was to translate the coordinates of the bug to motor speed, to motor step movement. So
there's some complexity here with regards to the position of the sprayer and the offset from the position of the camera, and even the you have to do some compensation to make them to kind of know where to spray, right?
Yeah, exactly. Yeah, we had to also calculate, because the angles of camera are not so straight, right? So we had to calculate the angles and the offset.
All right. Got another video here, it looks like.
I think that it will be the demo.
Yes, it's your presentation. Cool. Let's.
Yes. So we're gonna see the exactly the demo without the presentation.
There you go.
Yeah. So we're gonna see how it works.
Yeah. Go ahead and talk us through the what it's doing here.
Okay. So as we can see, the vehicle moves along the potato rows. They are real potatoes, and as you can see in the kernel, the corrado potato beetle is detected, and we're gonna spray pointwise.
My only feedback from this when we were looking at them for the competition was you should have added sound effects when it sprayed. It should have been like pew pew.
I was expecting the kind of music, the theme from the Ghostbusters here. I think it would be just incredible.
Yeah, we would definitely get a YouTube copyright strike for that one. We got to keep our monetization status. Phil needs coffee money.
So, and that's all. That's the whole demo.
Very cool.
I think
super love it. Like, if only I had this thing when I was 6, collecting potatoes.
That was my dream also.
I love it. Oh, let me see here. Go to the next slide.
I think that's all.
Cool. So let's talk a little bit about. I've got some more questions here. I'm going to unshare the screen. So, if people want to find you and Marta online, if they want to ask some questions, where are the best places for them to go?
I think the LinkedIn profile is a good place.
Then what's that LinkedIn profile?
Should I share on the chat or?
Yeah, please do. We'll also put that in the show notes as well. So we got some questions from the audience here. If y'all have more questions, please post them in the chat. Again, the Q&A and the giveaway, which we'll be doing in just a few minutes here, are only for people in the Zoom chat. If you're not in the Zoom chat, you can get there by going to opencv.live. Alex would like to know exactly how many images did you use? I saw you said like maybe some hundreds, but I think he wants a more specific number.
It was around 500 images.
That's significant. Did you use any kind of augmentation for these, or were they just all different images?
On that stage of the project, I was not aware of that because, as I said, we're new in the machine learning.
Yeah, and we did. It was not something I was really aware of either until I think we had Joseph Nelson on the show, and we talked about that for a while, about even just very simple, mirroring things, rotating them, how that can really improve the accuracy of a model dramatically. And so, I mean, it seems like this one works very well. Like, what do you have any stories of failures to detect or detecting incorrectly that are amusing, or that you had to solve through a different way?
Yeah, one thing which helped us was that we know we know the minimum and maximum range when where the bugs could potentially appear, because we know where is the potato row, and so we can limit and reduce amount of false objects.
That's interesting, is because they're you sort of know the distance, and so you don't have to worry about farther afield things, and that probably improves your detection percentage.
Yeah, exactly. We just work on the same distance still, so it helps to calibrate the camera and as well as drop the false appearance.
Dan would like to know, were those real bugs in the demo or model bugs? And I have a follow-up question. Where did you get the fake bugs?
So we have printed out and just cut out of the photo and just give them shape of the ball to
That's really interesting. So you made papercraft Colorado beetles.
Yeah, real size.
It's very interesting.
That's interesting. I was not expecting that. So I also wanted to ask, because I thought that maybe there is a kind of online shop for fake Colorado beetles. That would be fun.
Well, I know you can buy fake teeth in bulk on Alibaba now, so I mean, there's got to be a Colorado potato beetle
this is
seller
all
out
the
there.
information I was going to learn today. So thank you.
We tried and
You're welcome.
Shows, but...
Well, I mean, where do you buy your fake teeth? Next question. Stefan would like to know, did you have any way to, or did you have any chance to test on bugs that were moving? Would that affect the effectiveness here?
No, we had no chance, because there is like off season. Just in the March there was winter actually. So
when is when is the on season for these bugs, when they're going to be at their worst?
It starts now.
Yeah. Are we going to get an update where you take it out in the field? And I would love to see that. I think the audience would love to see that as well.
We need some more time.
Let's see. We've got Flander would like to know, what was the hardware provided by Microsoft Azure? What kind of GPU, what kind of CPU?
It was mentioned in the slides. Can we share it again?
I believe it was the DS.
The machine.
It was the DS3 V4. V2. Gotcha.
V2.
Gotcha. Thanks again to our generous sponsors at Microsoft Azure and Intel. So yeah, Niraj would like to know, how did you compensate let me read the question better here. How did you compensate for the difference in the camera position and the sprayer position to make sure that it was spraying in the right place? Like what kind of math was involved here?
So we created like so first we tried to rotate this position of the back to get the same angle as the robotic arm, and then we had to calculate with some matrix calculations the right position, and then we just translate it to step motors degrees.
Real math, honest to goodness math. Jesse Brockman would like to know who won the OpenCV Spatial AI Contest popular vote. We are going to announce that tentatively. The plan is to announce it on an episode of the AI show with Seth Juarez. So stay tuned for that. You will find more information on that in the OpenCV newsletter as soon as we have it. You can subscribe to that at opencv.org/subscribe. Michael would like to know, do you plan to develop the prototype and try to use it in a real world situation out in the field?
And we would like from me on this question.
Yeah, we would like to mount the cameras on the real machine on tractor and gather the data to analyze if our algorithms works correctly. So yeah, we would like to, but we're gonna see.
Is it just a question of just having the time to do it? I mean, it's a side project. Everybody's got day jobs, or is there some other, is that mostly the reason that it might not happen?
Yeah. Exactly.
Gotcha. Well, I mean, we need to start a GoFundMe to quit your job and build Potato Buster. that's the solution here, obviously.
Maybe that's the right.
So Michael would also like to know, did you really get to test it much on other kinds of similar looking bugs, like really large ladybugs or other kinds of common, maybe not even pests, just common bugs that you find out in the field? Some of them, are beneficial. They sometimes eat the pests.
Yeah. Yeah, we didn't try because I think that's not the case in the real environment. During the season of these bugs, there are just only these bugs are on potatoes. So I think that's not a problem. If we spray a little bit more chemicals.
Okay.
I would like to add my 2 cents here. So I believe that kind of with the way that the data set, kind of that you use to capture the data set, most probably like when you start testing out live, you will find that you want to kind of add more data from the real life fields. And once that happens, I'm sure that all these problems can be solved with enough data set, like enough like data and diverse enough data.
Yeah, that would be great way to improve our model because it's of course limited.
Yeah. C. Saba says there are Colorado Beetle models on Sketchfab. You could maybe 3D print some and do some model painting, or maybe I think you need a giant one. I think you download the model and blow it up like 100 times and just have a giant Colorado Beetle. That would be very funny. Serge says you should have used lasers. I think Serge is right.
That was also an idea, but that needs high precision.
My question to Serge is, why not both? Spray them with pesticide and then zap them.
This device would have both water and lasers. Like Phil would love it.
Two of my favorite things. You're absolutely right. It's the double tap. Spray them and then zap them.
I know what I'm going to do next competition.
Serge would also like to know, did you put any thought into calculating for the wind? This is a really interesting question to me.
No, not really.
Do you have any thoughts about how you might go about that? Because it need a different sensor, or possibly you could use the Raspberry Pi to hit up the internet or something to see what the wind direction is.
Yeah, but the time was too short. The deadline was really short for us.
Yeah. I just mean for future improvements.
So we went, yeah. We have to know that.
Yeah. Do you have any thoughts about how you might do it? Not really.
Not really.
Gotcha. Did you consider making the hose? So is the hose variable in any way? It seems like it just fills up the thing and then squirts, and it's the same distance every time. Did you give any thought to making that more variable?
Actually, it works in 2 axes, because there are only 2 motors, so we can rotate and stretch. We cannot. We need one more motor to get full control of the robotic arm. So yeah, there were no enough motors in the set to do that.
Gotcha. Let's see what else we got here. Richard says that a lot of self-driving car companies are using computer graphics to generate virtual environments to train their systems in. Do you think that would have been more efficient here, or could help this project to create a little virtual potato field and have your virtual bugs in there?
It's hard to say for me because I'm a bit inexperienced in that field, but I think that's the solution could potentially improve the product.
Jesse suggests that you could just check for wind, and if it's too windy, don't spray.
I
That's
actually
how it
agree
works in
because
real world.
It's smart.
I mean, I totally agree because with a certain kind of pressure from the pump, all kind of speeds of the wind up until a certain kind of level are negligible.
Yeah, yeah, it won't really affect because especially because
Yep.
it's such a short throw, as it were.
Yep.
Yeah, that's interesting. Um, David asks, with this specific choice of targeting system, does it affect what pesticides someone would choose to use? Would they use a different pesticide for this system than they would use for a larger like mass spraying system?
Probably yes, because if we aim point-wise on the bug, we don't have such a strong chemicals. So I think that's the case.
Interesting. Cool. I'm going to take a break here before we, if you got more questions, please go ahead and use the Zoom Q&A functionality to ask those. We're going to take a break here to do our giveaway. The way this works is that I'm going to ask a question based on the slides from this presentation, and you in the Zoom audience will have the chance to win $200 of Microsoft Azure credits from our generous sponsors at Microsoft. The question will be from the slides, and you have to answer it in the chat window there. If you have won the contest, if you won the trivia contest in the last 2 months, please do not answer the question. Give other people a chance to answer. So get ready to answer. During the presentation, we learned about the Lego set used to create this awesome robot. This is a two-part question. What was the name of the configuration used, one of the 5 available, and what is the name of the configuration that won last year's competition? You have to answer both. We got some people getting the first one. Some of them tried to jump out ahead of me. Man, Alex, Partha, get out of my head, Partha. Gianpaolo, close, close, close. We got, man, we're close. I see Zach. Zach is the closest here. He's got an extra letter, but I'm gonna allow it. The answers were MVP and Charlie. Congratulations, Zach. Please send one email to phil@opencv.org. Congratulations. You may recognize Zach from episode 48 or so of this webinar. He was Team LA Inoculum with the really cool bacterial colony counter project, which was another one of my personal favorites. It's always awesome. I know Anna and I would talk about this when we're doing this contest stuff. The best thing is when you see stuff that you could not have guessed you would see. And I think the Colorado Beetle Buster and LA Inoculum's bacterial colony counter were two things that if you gave me, a week, I wouldn't have been able to guess that we would see anything like these other two. So, congratulations, Zach.
And I also love biology, and it's thinking that it can kind of really help the research kind of just blew my mind. So yeah, thank you, Doc. Thank you, Doc.
Yes, absolutely. Let's see what else we got here. Serge suggests that you collect the bugs and make a bug burger out of it. Gross. Let's see what else we got here.
But if you eat it with a fake teeth.
There we got it now. You make the bug burger and eat it with the fake teeth. Richard would like to know, is the system fast enough to detect moving bugs? I think we talked about that a bit. Do you think it would be a useful improvement in the future, though, to try to maybe add to it flying bugs, flying insects, to be like, okay, where are these guys going?
Potentially, yes, but it would be hard to target these bugs, flying bugs point-wise, so it would be more like spraying something around.
Gotcha. Do you have any thoughts about what you would need to do to scale this up in terms of power and whatnot to use in a real life situation?
I think the most important thing is to try these algorithms, this model in the real environment. And the scale is not really hard to do, I think. I think that there are no limits to do that. We just need many cameras to record video from many angles and detect as many bugs as possible.
Right on. Jesse suggests, what about collecting the bugs with a vacuum? That's really interesting.
I'm not sure if it is possible because the bugs is heavy a bit. So it could
heavy
destroy,
heavy and sticky. They like sticking to stuff.
Grab leaves.
Yeah, I could I can imagine there'd be a lot of trial and error there with getting a vacuum powerful enough to get the bug and precise enough to get the bug, but also not damaging, putting mechanical damage on the leaves would be a difficult thing there. That could be really cool though to, I could see that being, for organic agriculture, for example, things that you can't use pesticides, or even maybe smaller bugs. This could be adapted with a vacuum for smaller bugs.
But then you can use lasers.
Well, I mean, there's nothing to say that you couldn't laser them and then vacuum them off to keep the plant clean. I think that might be the true way here. Zach suggests a tractor beam, maybe out of the price range here. I think, the classic Star Trek, tractor beam, maybe out of the budget. Partha asks about occlusion. Have you tried out the system when it can only see part of a bug? How does it perform there?
I was not really in the mind to get into such a details, but as far as I remember, it was working because the pattern of these bugs is quite simple because they are stripes, so it's easy to detect, even if there is only a part of the bug.
Yeah, I'd be interested to see how it worked. This brings up another question that the audience submitted here, which is, are you planning on open sourcing any or all of this, whether the code or the trained model, for example?
I'm considering that, but I have to look into the code and check if it is possible at work.
Just how embarrassing your code is now.
Yeah, exactly.
I used to struggle with this myself until I realized I don't care.
I think this is the right way to go. Otherwise, you would never kind of open source anything because there is no perfect code in the world.
Yeah, I think no fear with open source. Just put it out there. Somebody will either use it or think it sucks and not use it. Worst case scenario, I've actually had people hire me based on open source code I wrote that I thought sucked. So, I mean, it's not necessarily, I think it's only positive, really. Andre would like to know, could your apparatus battle cockroaches at home?
We have to modify our model, but it's possible.
I think it could be a very... Go ahead, Anna.
There would be a robot vacuum cleaner and robot cockroach buster. I think this is smart. You could actually unify them into a single kind of apparatus, right? It kills the cockroach and then vacuum cleans that.
It shoots the cockroach with a laser, then it vacuums it up. We've solved it, everybody.
There should be safety somewhere in this construction.
I think it's too complicated for free-month project.
Yes, definitely. Especially here in the city, you're going to see a cockroach or two out here just occasionally. Welcome to San Francisco. Any more questions, please? We're taking them. We're continuing to take them. We got about 9 minutes left. I have a couple more questions of my own, which are: Do you plan to do any more improvements to this? We talked about maybe bringing it out into the field, but is there any? Do you feel like energized to keep working on it, or are you kind of like, well, we did well in the contest, and now just move on to the next thing? What's next for you?
Yeah, I think that's a cool project, but the next step is to get the data from real environment. That's must have to continue with that project to check our possibilities, what we can do with that approach.
Yeah. I personally would like to see a simulated potato field with the fidelity of the Unreal simulated city they used in the newer Matrix movie. That'd be pretty cool. I would just go hang out there.
That would be
Yeah, just like
No, this is an idea for metaverse.
yeah, just walk out into the potato field and sit there for a while. That sounds nice.
And then huge Colorado buses, like
Gigantic,
Beetles.
the size of a city bus,
And you have a laser to kill them, huh?
and
Oh,
a
that's
vacuum. You have to fight them with a vacuum cleaner. It's like a dust buster, you know, a little handheld battery guy. That's going to be my next Unreal Engine demo, obviously. Let's see, some business here. OpenCV weekly webinar, we've talked about this before, is getting our own virtual production set. We will be using the same set from OpenCV AI Game Show. It's being modified by our friends at Light Twist. We'll hopefully have a little demonstration of that maybe next week or the week after, and then we'll start using it for every episode. We're really excited about this. Thanks so much to all of you who watch the show every week. It would not be possible for us to do any of this stuff without your support and your enthusiasm and your work on these competitions, because a lot of you, submitted things for that, and thanks so much. Thanks, Anna, for joining us. Do you have any last words for the episode? Would you like to promote or pitch anything, Anna?
No, not at this time. I just wanted to join Phil and saying thank you so much for joining. I still am kind of super surprised by the large geography that we have here, which makes me feel that we are kind of united in this interest to computer vision and busting Colorado Beetles.
Yes, together we are mighty. Michał, any last thoughts for the people in the audience? Anything you'd like to direct them to, website, anything like that?
It was an honor to be here, and thank you for appreciating our project. I'm glad, and thank you very much.
Thank you very much.
And participating in this competition was really fun. I recommend for everyone with some idea, even if it's killing up bugs.
And if that isn't the perfect thing to end the episode with, thank you so much for joining us. Thank you so much for watching. We will see you next week. Same bat time, same bat channel, 9 a.m. Pacific. Take care of yourselves. Take care of somebody else. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by Intel and Microsoft Azure as part of OpenCV's Spatial AI contest. Follow along with the OakDLight contest hashtag. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.